You know, every single day we're sending and receiving just tons of information across the internet, and we really don't give it a second thought. But underneath that super seamless experience, there's this complex two-way journey going on. So today, we're going to pull back the curtain on the hidden mechanics of that journey, the forward and reverse paths that make the whole thing work.
Think about it. It's something you do dozens, maybe even hundreds of times a day. You see a link, you click it, and boom, a web page appears. Simple, right? Well, not exactly. The story of what happens in those few milliseconds, that's the entire story of how the internet works as a two-way street. So let's follow that click and see where it goes. So where does it all begin? Well, our story starts with your request. This is the first leg of the journey. You can think of it like a message in a bottle you're sending out across this vast ocean of the internet. This is what we call the forward path.
All right, so what exactly is a forward route? Honestly, the best analogy is just sending a letter. You write the destination address on the envelope, you pop it in the mailbox, and the postal service takes it on a pretty specific route to get it delivered, right? In the digital world, your computer's doing the exact same thing with data packets, sending them from you, the source, all the way to the website server, the destination.
The forward path has a single-minded mission. Its job? Super simple. Deliver your request. That's it. It's a one-way street, always moving from the source to the destination. A classic example is your web browser, just asking a server for a web page. In fact, network engineers have this really cool tool called traceroute, and it literally lets them map out this exact journey, showing every single hop your data takes to get where it's going.
Okay, so your request has arrived. Mission accomplished. But that's only half the story, isn't it? Now, the website server has to send that web page back to you. This is the journey home, the reverse path. And this is where things get really interesting.
So the reverse route? It's got an equally vital job, but it's the total opposite of the forward path. Its only purpose is to guide the response, whether that's a web page, a video, whatever, from that server all the way back to your screen. It's the destination sending a letter back to you, the original source.
And this right here? This is probably the most important thing to get. The return path is almost never a perfect mirror image of the path it took to get there. Your data might take one highway to its destination, but take a completely different set of backroads to get home. Now, why would it do that? Well, the internet is this living, breathing network. It's constantly shifting. Maybe the first path is congested with traffic, or maybe a different network provider has a better, cheaper route for its return data. The internet is always calculating the most efficient route in that exact moment, and the best way there isn't always the best way back.
Let's just look at this side by side, because the contrast is just so clear. On one side, you have the forward route. Its whole purpose is to deliver your request, moving data away from you. On the other side, you've got the reverse route with a totally different job, guiding the website's response back to you. They're two sides of the same coin, but each one has a distinct and absolutely vital role to play.
But you know what's really cool? This whole reverse idea isn't just about how data gets from point A to B and back. This dynamic, this forward and reverse concept, it pops up in some of the most important areas of technology. Everything from network security to how web servers are built. Let's explore a few of those.
We're going to touch on three really fascinating applications where this concept is a total game changer. Reverse DNS, a security technique called reverse path forwarding, and something you've definitely interacted with even if you didn't know it, reverse proxies. You'll see, this idea is everywhere once you start looking for it.
So let's start with DNS. You can basically think of it as the internet's giant phone book. Now, forward DNS is what you use all the time. You type in a website name and it looks up the numerical IP address. Reverse DNS, as you might guess, does the exact opposite. It takes an IP address and asks, hey, who does this number belong to? It's like having someone's phone number and using it to look up their name. Okay, now let's talk security, because this is where the reverse path concept becomes a seriously powerful tool. It's called reverse path forwarding, or RPF, and you can think of it kind of like a bouncer at a club who's checking IDs to make sure you're actually supposed to be there.
Here's how it works. And honestly, it's so smart and simple. First, a router gets a packet of data. Then it looks at where the packet says it came from, and it asks itself a question. If I needed to send a reply back to this guy, would I use the same path this packet just came in on? If the answer is yes, the path makes sense, and the router says, okay, you're good, and lets it through. But if it arrived from some weird, unexpected direction, the router assumes something's fishy and just drops the packet. It's a fantastic way to help stop attacks where hackers fake their address.
And finally, let's talk proxies. Now, a forward proxy, which you might see at a big school or company, sits in front of you, the client. It handles your outgoing traffic to protect your identity.
But a reverse proxy does the opposite. It sits in front of the website's server, and it manages all the incoming requests. It does critical jobs like balancing traffic or handling encryption. The easiest way to remember the difference is to just ask, who is being protected? A forward proxy protects the user, a reverse proxy protects the server.
All right, we've gone through a lot here, from data paths all the way to security checks. So let's kind of zoom out for a second. Why does this fundamental difference between forward and reverse actually matter in the big picture?
If you take away anything from this, let it be these three things. 1, every single click you make is a round trip, a complete two-way journey. 2, the path there and the path back are not the same. They are two distinct routes with two very different jobs. And 3, understanding this difference is absolutely essential for anyone who's involved in network security, troubleshooting problems, or building the web we use every day.
So, the next time you click a link, just for a second, remember that invisible journey that's unfolding in an instant, the forward request blazing a trail, and the reverse response finding its own unique way back home. The internet is built on these elegant, invisible rules, and it really makes you wonder, what other ones are out there, quietly guiding your every single digital step?